Hello, work power energy chapter ating a video masapen na. So masapen na hi work done ibol di hintin. Work done ibol masang chadwachu constant force to variable force kiti hi akihi na chupi ha. Masapen na constant force kiti pala chun constant force constant kiti chu kihielo. Okay, it is same throughout the whole motion. A force part kihielo na it does not depends on time. Okay, it does not change with time. A variable hong kiti pala chun force part it can change with time. Okay, it can change with displacement, right? Okay, some example. For example, F equals to 2I cap Newton. Okay, 2I cap Newton kati ala chun hechi force pa hai na magnitude chu 2 Newton hong hiding. Direction chu hilang ha direction chu along the positive x axis. Okay, I cap chu positive x axis chula na. And hechi force pa hai 2I cap pa hai, so it will be 2I cap throughout the whole motion. Okay, ki hello this is Japan here. See, one more example, F equals to, I can also write like this. Suppose 2I cap plus 3J cap plus 5K cap Newton. Yeah, here's a force repeated. So 2I cap means along the x-axis you have 2 Newton. Along the y-axis, 3J cap to along the y-axis 3 Newton. 5K cap to along the z-axis 5 Newton. Okay, right? So this is an example of constant force. Okay, so a force x lang acho 2 hi hijing din na, y lang acho 3 hi hijing din, z lang acho 5 hidan de. Okay. It's a constant force na, force that does not change with time or that does not change with displacement. In a variable force ito bang ha. Suppose to hi force pa hi na ita hi 2x I cap kan si ala chun. Ake ba alon so piha masapen to kon. Masapen na 2I cap is ani na hi 2x I cap kasi chun na si here. So now you have some x here, you see. X pa hi pikitia. Met ako variable kati chun na. Variable kati chun hi value anom na ba ala thai cho. So I can put here x equals to 1. Okay, x equals to 2, minus 1, minus 2, and so on. Okay. Batang hichi force hi x equals to 1 ka put ale force is at the ha 2I cap. Na x equals to 2 ka put ale chun force is at the ha to 2r 4I cap. Okay. So x equals to 3. Force at ham to 3r 6I cap. Cha ko na se pine observe force pa hi it changes with x na x ki hial chana cho force on ki hial tinai cho, so x equals to 1 as a force to 2, x equals to 2 as a force to 4, like that. It keeps on changing as x changes. So force depends on x. Chala x pa hi variable kati cho hiche variable omji hi force pa hi variable force na. Batang example dang pya ita jong ko ji thai cho. So 2x I cap plus 3y j cap na plus 5 say z k cap z square rong ji theu na noble y cube ta jong ko theu cha power cha nom nom thai e wanga chu apoi mo pa cha pya variable pa he na y oma chala z oma chala hi x Okay, so you have variables. So here with for different values of x or different values of y na or different values of z, so this force is going to change. Okay, right? So this is an example of variable force. Atile to hi work done pa hi constant force a work done bolio, variable force a work done achum suman bolio na must have been a constant force on about so if I have a constant force, work done will be force into displacement F dot R. Okay, hichi force ipiham hichi displacement hi ipiham detail line bolio cho must have been a simplest application of this na example ga boleng. Suppose force khat hin force pa chu, let's say 2I cap na plus 3J cap plus say K cap force khatum cho Newton. Hichi force hin object khat chunga he na, so this force acts on an object. So let's say so this force pushes an object from from 1 comma 2 comma 3 to b to let's say 2 comma 4 comma 5. Okay, atila cho object chu chelai coordinate ai omna point ya hi object oma hechi force pa hi object chunga ahong eka chu an sora chu pm dele hechi object hi a para b chan ke tol ta chu. Okay, right? So it has moved from A to B. So these are the initial and the final position. right? So here in this formula, r pa hai na che pa hai, he che pa hai pyam. So this is displacement, okay? Or you can say displacement vector. Betang, basic maths are displacement vector balls. Na vector video acho. Hita he tang he I can write this whole thing as r initial, so which is 1 into I cap plus 2j cap plus 3k cap. So any vector can be any position can be written as a vector. Chicho position vector ke dicho na. Position vector of b cho pe ha. So rb, ra. Chicho 2I cap plus 4j cap plus 5k cap. Okay. Atile a para b ka chia chun b cho final heza a cho initial chola na. Atile displacement vector cho pe de ha. So r final minus r initial. Okay. Right? So if you solve this one, what will you have? So I to I so minus bola chun 2 minus 1. Na chicho that ha. So 2 minus 1 2. So I have here 2 minus 1 plus 4j minus 2j. Okay, so 4 minus 2j plus 5 minus 3 k cap, right? So from here you have I plus 2j plus 2k. So this is your displacement vector. Direct ana he cho jong hi avial vela ji ngalo pichi cho he. He coordinate on ki pi ala chun na coordinate ahin direct and minus bol chun. So a para b ka chi ala chun final minus initial 2 minus 1, right? 1 is 4 minus 2. Okay, 5 minus 3, like that. Okay. Hatile r ma f ma la chun force to be work done to be ta. So therefore work done equals to force dot r bar. Okay, force to 2I cap plus 3j cap plus k cap. Okay, so dot I plus 2j plus is that 2k. Okay, dot product ke bolan chati ki bolita like terms I dot I to 1, j dot j to 1, k dot k to 1 na. All the rest of the term are 0. Okay, I dot j, I dot k all are 0. Just dot product ke bol phale hin like terms so direct multiply na bol deu. Okay, right? So 3j and 2j multiply, right? So k and 2k multiply. Tile za thong pot hala him 2 into 1 plus 3 into 2 plus 1 into 2. So which is 2 plus 3 2 are 6 plus 2. So which is 10 joules. Unit of work is joules. Oh, energy in bot phale in say ke thotho diuza. Atile chelai question ahi work done pa chu 10 joule na. Formula I manu chu beta. So force so kpr h r pa he pm. So r pa he displacement vector. Okay. So this is a displacement. Okay. Tang asim chisanga so able sanga simple zo lang question kisim thai cho. For example, force to be force to, let's say it is given 2I cap Newton. J cap k cap jaw lo hela na. Ale h force hi object khat chunga khana hi ek cho na. So let's say this force is acting on an object. Okay. H force by an object khat cho push cho na push le. Let's say it pushes an object from let's say from 2, 0, okay, point A to B is let's say 4, 0. Okay, force 2I cap chun block khat chu object khat chu 2, 0 para 4, 0 chun push ale work done chu is that them. Okay, what is the work done? But the formula chu pm formula chu work done equals to F into R. Okay, so like this na. Alehin chilahi R pa hi na. To hi general formula in jidu cho che pa hi. So in general work done formula pa hi na. Work done is equals to F dot R. Hichi R hi pi ha. F dot so X I cap, right? Plus Y J cap plus Z K cap. Okay. Chicho kisi dam tele betang chelahi force pa hi na. Displacement pa hi along the x box here lachun you can take only x here. Okay. If it is along the y only you can take only y. Kasaidan chu piham tele work done chu motion chu along x box here lachun force equals work done equals the force dot x ta ka chi thei chu. Okay. So work done so only along the y hi ala chun f dot y ta ka ji thei cho ai work done so xy plane a chi ala chun so force dot xi cap plus y z cap ita hi na ka ji thei dan cho okay so here you can remember this one if you want. Chilai question I value on motion pa hi along the x-axis bo so na force pa hi along x-axis a chi cho okay along the x. So if the force is only along x-axis then you can take only this one. Okay, right? So then what do you have? So work done equals to force to 2i cap dot displacement to ha betang 1 2 3 4 na chi x-axis atila a chu hoi lai ha a chu 2,0 chilai 2,0 chi hi a abana pa chu 4,0 chi hi b na atila displacement chu biham 2 upon force and hi changni. Okay, so which is 2, right? So I can write here 2i cap into 2i cap. Displacement chu along x-axis chula na atila chun chu 2i cap ka chi thei do chala hi hi chi za ding ham. So I dot I chu 1 is a to 2 are 4 joules work done chana. Okay. In most of the case, okay, questions so you will use mostly you will use this only. Okay, so f dot x or f dot r like this. Okay, right. So let's move on to the next one. Suppose I have a block at the time. So na block chunga hi. So a force is acting. So at an angle, some angle theta. Okay, like this. At the question to block pa hi a chang dem. Chang de chuna block pa hi hui lang ke tol ding ham chelang ke tol da so. So let's say some acceleration is along the side. At the h force pa hi x lang azong umlo, y lang azong umlo na. So it is at some angle with the x-axis. Okay, it is not along the x or y. So we take the component. Component gala leo chun hilanga hi f cos theta amding. Okay, hilanga hi pm dia hilanga hi f sin theta. Ne. Atile hin block chi lang hi horizontal cho na. So question is which of these two is responsible for this motion? Which pen ji ahena which pen component ji ahi block pa hi ke tol hi dem. Block pa ki tol na lang hi value chun horizontal cho. So which means that this force is responsible for the motion. F cos theta bo se hin h bo se ji ahi block ki tol cho chelanga hi. H f sin theta hin effect ima sa nei lo cho. Okay, so if the force does not have any effect on the movement, then the work done due to that force is 0. Okay, so there is no work done due to f sin theta here. So the work done is due to f cos theta. Okay, so the movement is due to f cos theta only. So therefore you have to calculate work done due to this f cos theta only. Okay, atila work done chuzat deha force into displacement f cos theta into, let's say it goes by distance displacement of r. So I have to write r. So which is fr cos theta. Okay, chichu work done na. Hichela formula jong hibela chun dot product so dot product si pha la khun piung po jiang cos theta po ji chule na. So another way of explaining is this one. Okay, about the next point so ha chelai force component ni hibela chun na. So one component is along the displacement. Okay, displacement so hilang ha horizontal chula na. So one force is along the displacement, another force is perpendicular to the displacement. Okay, so there are two components of force. So one component is along the displacement, another component is perpendicular to the displacement. So see kasi banga chuna hechi, so the component which is along the displacement is responsible for the work. Okay, the movement. So work done ahi nanji phare na. So when you write work done, you write f dot r or fr cos theta. Okay, so when you write work done equals to f dot r. So what is this f? Or you can say f r cos theta. Chalai f hi piha. So this is the component of force which is along the displacement. Okay, you can write like this. So component of force along displacement. Okay, work done formula na work done ko metang force into displacement is a force paku. It is the component of force which is along the displacement. So remember this one. Okay. Aban jon hotel F ki chaita na azwa R2 p seuta R2 displacement into chula na. So let's go a little bit deeper into that R. Atela chela hi for example hi chela hi sponge kanai cho sponge ne na. So SPONG. So you can press it, okay. Kimi email ki di form thai na tu hin chi sponsor a hin force kha apply leuchen. Okay, so let's say this is a chala wall khalom na chala hi wall khabun tin sponsor pas a force apply leuchen pitire hun ki di form dis na. So you will get deform like this. Okay, you will get deform like this. Force pa hebela chun chi F na atila chu hichila hi omisa na push vala chun hi cha ke tol fading intin. So now it will be here. Okay, apoi mo so point of application pa hebeta. So this is the point of application of force. Okay, when you push it, so the point of application has now moved to so this point. Atila question 2, is there any work done here? Chala hi work ke bolam. Body hi velocity body hi travel lo puchula na. The body is not moving. Okay, the body is not traveling, but you see the point of application of force is moving. Okay. Point of application of force ki apply na point jo acha la chun na. So there you will have work done. Okay, so like work done formula R pa hai na hichi R pa hai pm. So this R is the displacement of point of application of force. Okay, point of application of force. It's a point of application by displacement ngai so it's point pi. Okay, so if there is a displacement here, then there is work done. Okay, remember that one. Atile in detail it's a detail formula that's work done constant force. So constant force work done is a force into displacement na. So a force is perpendicular component of force which is along the displacement r to pm displacement of a point of application of force. Okay, so that is work done. Right. So here quick revision. So work done is the product of component of force along the displacement and the displacement of point of application of force. Okay, it's a work done definition na. Ale one extra point. Okay, suppose uniform circular motion here na. So particle is revolving around in a circle. Okay, so whenever a particle is revolving around a circle, the head okay so centripetal force jana si bol that's last chapter acho. Ale at any instant particle have velocity hoilangama. So velocity is along this side. Okay, v bar. Ale force hoilangama. Force to centripetal force. It is towards the center. Centripetal force na. Ale hin sila ko na hipi heta force to hin velocity perpendicular. So and question 2, if the force is perpendicular to velocity, so will there be any work done? Work done on them. But work done formula sapita. So work done equals to F dot R. Okay, displacement. So we have displacement to velocity into time. So atile F dot V into T. Kutile V to chun F to perpendicular hile chun. Chila F dot V hi piha F V cos theta chulana chahi. Atila theta hi angle between F and V. So ani ni hona perpendicular here chun theta to 90. So I will have here FV cos 90. Cos 90 value to be 0. So cos 90 is 0. Therefore the work done is 0. Right? So that means uniform circular motion ahi na. Uniform circular motion ahi. So here the work done is 0. Okay, work done is 0 because the force and the velocities are perpendicular. Okay. So one extra point na chala hai. So centripetal force is always perpendicular to the velocity. Therefore, the work done in uniform circular motion is 0. Okay, theory is anjuna constant force. A question khaleni ga solve fatin. First question 2. No work is done by a force on an object. No work is done kiti chuphe work done 0 tina so chala hai. So work done is equals to 0 if the force is always perpendicular to its velocity. 2I bolsa do na uniform circular motion aso. So this is correct. Force to velocity to perpendicular here chun work done to 0. And in a force is always perpendicular to its acceleration. Hechi hina, suppose you have a non-uniform circular motion. Chilai hopitizia centripetal force pa na. You have AR along the side, and then you have AT along the side. Okay, you have V along the side. Alechun chilahi due to centripetal force, work done is 0. Okay, chichu ki hena chuna jichu force to hin velocity perpendicular. So ahivanga there is additional force here. Okay, if you have acceleration along the side, so which means there is additional force on this side, right? So in that case, so the work done on the object might not be 0. Okay. As you force danga mala chuna azo aftang block ball long. So suppose so I have a block here, right? Along this side I have F cos theta. Okay, along this side I have F sin theta. Atilachon block chu chilanga chi chulana, so has some acceleration. Chila heavy due to this force, okay. Due to this force, work done is 0. But the work done on the body, on the object is not 0. As it's a force dang sa chila chila hi. Na acceleration chu chilanga isa force chu chilanga hile amani perpendicular chila na. Amani perpendicular hile chun due to this the work done is 0, but there are some other forces due to which the work done on the object is not 0. Okay. Atilachun option B na chu di law na. C na khopi ha. Object is stationary, but the point of application of force moves on the object. Tang hita hi object kanaya. Force to khabele hila ki apply z, khabele hila ki apply z, khabele hila ki apply z na. Atile hin object pa hi is at rest. Okay. Point of application ng vela chun chilo pisuna ta ke tolo pisula. Only where you apply the force is changing. Okay. So therefore here the work done is 0. Okay. Work done is amlo chula hi. As you displacement of point of application umlo chula hi. Force ki apply na both as you ki khel le jana chula hi. Okay, so therefore here so the work done is 0. The last point ko vela chun pikitia. So if the point of application of force remains fixed, point of application of force to if the point of application of force is not displaced, it is not moving, then the work done is 0. Okay, this is work done definition ta na. Okay, so therefore A, C, and D. Abana, a block of 5 kg slides down an inclined plane, 30 degree, length 10. Find the work done by force of gravity. Hita hi inclined plane khatoma, chi 30 degree hintin. Chila hi 5 kg na chila 5 kg block oma 10 meter ki slide su tina so so 10 meter hum ki slide su ding. Find the work done by gravity patang thaleu chun ki tol so dis na ibola ki tol so ham tele gravity so. Okay, so there is gravity. If I draw the free body diagram of the object, mg chu hoilanga ma, so vertically downward chula na mg chu 50 newton. Abale adang ho chu pipam inclined plane bolwa force ho chu hilanga hi, so 50 sin 30 ding. Okay, silanga hi pima 50 cos 30 chuna joy memele ta atile hita hum ki tol so ding tin distance suja ji de ha, so it will travel 10 meter. Okay, 10 meter ki tol so so khutile chela he vela chun due to gravity ya hi force is anama force jong hi oma jong hi chuna chela hi component ni so ale work done formula to dong ju ya chu hui pen hi la de ha. So the component of force which is along the displacement, okay, perpendicular pa hi kila laude. So work done due to the perpendicular component is 0. Hatile work done chu ham work done equals to force into displacement to 10. So 50 into sin 30 to 1 by 2 into 10 is that time. So 2 5 are 10, 5 5 are 25, 250 joule. Okay, so that is the answer. Next question: a man moves a straight horizontal road with a mass mass block so mass block to 2 kg na. So 2 kg block so if he covers a distance of 40 meter na so with an acceleration of 0.5 meter per second square. Okay, so the work done by man on the block, the work done by man on the block during the motion. Atile chun batang chila hi mass kpia acceleration kpia chun force na hold athayu chula na work done to force into displacement hisa. Atile chila force is at ham m into a, so 2 kg into 0.5. So which is how much to 5 are 10, 1 Newton. Okay, 1 Newton force. So therefore work done equals to force into displacement. So force to 1 into displacement to 40. So this is 40 joule. Okay, so one very simple question. Okay, bana a particle moved from R1 kPa, R2 kPa, force on kP na. Ale work done by force on the particle during the displacement. Batang kasi banga chu chi position vector khat chu chi pen hi. Chung position vector khat na chu pi na ham dele atila hi let's say R1 chu p tiu te 2,3 a particle ma chilai para hi next point chu q tiu te 3,2 chana hi particle hi kitol chu due to this force. Force 5 I cap plus 5 j cap ohm ja hai na object pa chu particle pa chu 2,3 apana 3,2 chan kitol ti ne chu it has traveled atile jun displacement vector chu ti ji ta r is equals to r2 minus r1. Okay, you can subtract this and this. Okay, otherwise you can simply subtract here 3 minus 2 I cap na 2 minus 3 j cap like that. Okay, so here 3 minus 2 I cap plus 2 minus 3 j cap. Is that the so I cap minus j cap. See displacement vector. Okay. Atile force jong kipi na force jong uma r jong ta work done to piham work done to force dot r. Okay, so force to 5I plus 5j, right, dot I minus j dot product to I j na na. So 5 into 1 plus 5 into minus 1. So 5 minus 5 is equals to 0. Okay, work done is 0. Right, next. If force F is given, it undergoes displacement X is also given. What will be the value of B if the work done on the particle is 0? Work done ki pichu chana hai. Okay, work done is given as 0. Force jong ki pi displacement jong ki pi na formula direct and apply eva B no hold like it's sizing. So what is work done? Force dot displacement. So here what is force? 2I cap plus BJ cap plus K cap dot displacement to be I minus 2J minus K. Okay, so this is given as 0. Ale dot product so like terms na 2 into 1 plus B into minus 2 plus 1 into minus 1 equals to 0. So like so 2 minus 2B minus 1 equals to 0. Okay, so therefore 2 minus 1 equals to 2B. So like so 1 equals to 2B or B equals to 1 by 2. Okay, answer to B. Okay, next you have work done by variable force. So when the force starts to change. Okay, formula to piham so integral. Okay, physics ahe na. Physics ahe whenever a quantity or a vector, a quantity starts changing. Okay, starts variation. So then we have integration. In general, so dr ka kaji penchuna so f r chupita. So f dot r ki phala chun r pa hi x jong thai y jong thai z jong thai chula na. Okay, so similarly I have integral f dot dr. So here dr can be dx, dy and dz. Okay. Athuma jong thai nibo se jong thai kha jong thai cho. So you can only have dx also or you tang chila along the x-axis. So most of the questions are based on this one. Okay. Most along the x-axis, force applied to along the x-axis bo hiala chun x-axis bo hiala chun force work done to f dot dx ta direct an jithe chu dr hiala hai na ai force to x to y ahung mala chun, so you can write up to dx and dy. Okay, but if it has all the three, then you can write all the three here. For example, force had to f to ham. So let's say this force is given as 5 plus 10x. Okay, Newton. Chiki na force cho. Alahin chi force here. So this force x on a particle, let's say it displaces the particle from P, that is 2,0 to another point Q, that is let's say 5,0. Okay. Hutele force khat hin particle khat hin na. So p that is 2 comma 0 apara 5 comma 0 chan hi a displace question so what is the work done atile achunga formula ko velo chun work done chu pm so work done equals to integral f dot dx sila hi bola dx cuz ham tele force hi beta so it depends on x only okay displacement jong hi sila para hi sila hi na force is along the x only okay atile sila hi dr hilai dx direct as it is so here what will be the force to 5 plus 10x okay dx abale x langa hai na along the x axis from where to where it goes from 2 to 5 na x relation x component pa hai okay so from 2 to 5 that means the limit of this integration will be from 2 to 5 chila integration bolan he rungai na is that data chila so you'll have tam nium chila na chila 5 to hin 10x yom so you can split them okay so I will have here integral 5 dx from 2 to 5 plus integral 2 to 5 that means 10 into 10x dx okay 5 is constant nala do valation dx dan na integral dx 2 to 5 dx plus 10 so nala do valation integral 2 to 5 x dx chi integration jar ha dx ko x na integration of dx is x from 2 to 5 plus 10 into integration of x whole x squared by 2 okay from 2 to 5 okay limit he put velang solve 5 na put value 5 into 5 to 25 minus 2 na put value 5 into 2 to 10 okay plus 5 na put value 5 are 25 by 2 right so how much is that 10 into 25 to 250 by 2 okay 250 by 2 to 125 minus 2 put legend so 2 squared by 2 to 4 by 2 to 2 2 into 10 2 to 20 na 2 into 10 to 20 so how much is this so 15 plus 105 so answer is 120 joules okay answer na so let's do one more example so that has all these variables okay for example force khatchu let's say force 2i cap okay variable force lena 2xi cap let's say plus 3y square got you y square z cap okay plus z k cap okay so this is a variable force so this x on a particle khatchu let's say it displaces the particle from origin na 0 0 0 apara hai so some other points so 3 4 5 tiute okay chi force in object khatchu particle khatchu p apara q chan a displace na atile work done chu is at the ham so question is what is work done right so here see to heavy load force a hi x zonguma y zonguma z zongum ta chana zela hi so therefore when you write the formula so work done will be equals to integral f okay so here you'll have so dx I cap plus dy z cap plus dz k cap athoma ne ta cha na force a hoi pedale atile hen force to hin koilo chun so integral force ko 2x I cap plus 3y square z cap plus z k cap okay dot so dx I cap plus dy z cap plus dz k cap dot product no bol theu chura na dot product bol le chun tam thumngum chu jela hi so this and this is one term so this and this is another term this and this is another term okay tile jela hi 2x into dx khat honguding okay integral plus 3y square into dy khat honguding abana chu integral z into dz okay chu tam thum na dot product bol sai leu chun ale x pa hi hoya par hoya che ham x pa hi 0 apara 3 chan chi chu okay atira limit chu 0 to 3 y pa hoya pa chiam 0 apara 4 chan chi na y pa hi so limit is from 0 to 4 z pa ho 0 to 5 okay integration bol leu chun integration of tang 2 pi hung pod this is integration of x to x squared by 2 okay from 0 to 3 plus 3 constant integration of y squared to y cubed by 3. Okay, from 0 to 4. Plus integration of z to z square by 2 from 0 to 5. So 3 who put 3 3 are 9. So 9 by 2 into 2 2, you'll have 9. Okay, plus abana 4 who put 11. So 4 cubes is an half 4 16 16 4 64. Okay, plus okay, wait to calculation. So 2 into 3 who put values 3 3 are 9 by 2 plus 3 into 4 put values 64 by 3. Okay, plus 5 put values 25 by 2. Okay, use all these values, solve that one. 2 2 cancel out, 3 3 cancel out. So 9 plus 64 plus 12.5. Is that the answer? So 9 plus 64 to 73. 73, you'll have 85.5 joules. Okay. All right. Question ni bosia bolu tena. So I think that is hetim tawin tena. Okay, apply answer. Okay, so next we will start solving questions. Okay, first question on variable force. Nasa pena hi. Force to kipina a plus bx kipia a to b hi constant. Okay, you can take any value. So find the work done by force during the displacement from 0 to d. Okay, force pa heavy along the x direction ba na. Atile work done so I can write as f dx. Okay, directly. Force so a plus bx into dx. Okay, limit is from where to where? From 0 to d. Right, so term niya ending from 0 to d dx plus from 0 to d bx into dx. Okay, so how much is this? So a into a podolation dx integration to x from 0 to d plus b podolation integration of x to x squared by 2 from 0 to d. Okay, so I will have a into d plus b into d squared divided by 2. Okay, so this is your answer. Okay, next question. A force is given. Work done zongkipina. Work done so 5 joule is given as work done. So when object is displaced by 1, okay, then what is beta? Okay, alpha is given. And the force is force to 1 plus beta into x squared. Okay. Atile work done formula so direct in apply logic. Work done to integral f into dx. As it's a force to x depends. It is along the x direction. I can simply write dx. So integral force to 1 plus beta into x squared into dx limit to is that 1 meter displaced to 0 to 1 kasi ito sila here. So here I can split into 2. So integral 0 to 1 dx plus integral beta who common za integral 0 to 1 x squared dx. Okay. Tile integral dx to x is 0 to 1 plus so beta into x cubed by 3. Okay, 0 to 1. So this is given as 5 joule. Okay, work done so 5 joule ki pichula na. Ale value po 1 plus beta divided by 3 should be equals to 5. Until it's beta by 3 to that hamponam. So 5 minus 1 so 4. Okay, or beta is equals to 12. Okay, option C. Next, a particle of mass m moves in a straight line with velocity given as a into root x. Okay, so v is given as a into root x. Sila para hitir kan niya diyo utang velocity to acceleration relation kan vet. Sila kon. So v is equals to acceleration is equals to v dv by dx. Formula kan vet kinematics sana. Hichelai small a pa hichepai constant. So don't get confused with acceleration. Until hichelai chi formula ka manu malachun v dv by dx ka hongai so chilai. Okay. Tang chi v into dv by dx so chilai. So I have to differentiate this dv by dx with respect to x. Ka differentiate alachun a to constant na. Chi betang chi pa a into x power 1 by 2 dinai root x cho. So x power 1 by 2 ka differentiate alachun 1 by 2 jung kum hading x power 1 by 2 minus 1 to minus 1 by 2. So this is a divided by 2 into root x. Power minus to denominator achi so dina. Power 1 by 2 to root. Okay, so this is dv by dx. Ati let's say like dv by dx kamuta acceleration to that term. So therefore, let's say acceleration to a dash tiute. Acceleration tata pana aji like constant khat he a jong hin constant is achu confuse loading wa chu acceleration pa chu a dash kan ji chu jala he a dash to v into dv by dx na so a dash v to pm a into root x dv by dx to pm a divided by 2 into root x. So root x gets cancelled out, so a square divided by 2 this is acceleration. Okay, until a mass ki pizza force ki whole thing na force is equals to mass into acceleration. So mass into acceleration to a square divided by 2. So which means ma square divided by 2. Work done to pdm work done to force into displacement. Okay, so therefore work done equals to force into displacement to pm 0 apara d chanji na hijila hebadang hiji force pa hebela jun constant ham variable ham adi ta depending constant part as body weight and constant force or depend here mass is a pa jong constant chula na ji 2 jong constant, so force is constant. So that means force into displacement from 0 to d is d. Okay, there is ma square divided by 2 into d. So ma square into d by 2. Okay, so that is the answer. Okay, one last question on inclined plane. A block of 2 kg is pushed down an inclined plane of inclination 37 degree with a force of 20 Newton. Parallel to the incline, inclined plane angle to 37 degree. Block hat na block pa hi PTM 20 Newton in assault su force hat in. Okay, assault su in le acceleration of the blocks is at so 10 meter per second square. Okay, until the question is mass to 2 kg. Okay, first question is work done by the applied force in the first second. Okay, what is work done holding also displacement ngai so na displacement to almost at pen so x equals to ut plus half at square. So like u is at so if the block starts from rest so u to 0 na atile 0 into 1 second plus half into acceleration to 10 into 1 square. Okay, till is that to 5 are 10 1 second at displacement to 5 meter. Okay, hotel a part to pm a part to work done by applied force. Okay, so that force into displacement. Okay, F into D. Force is 20 Newton na into displacement of 5. So this is 100 joules. Question due to applied force at applied force boss. Okay, only 20 you have to take. About the next question should be so due to the weight of the block. So now this is the weight of the block at weight of the block considered you. To hi block pa hi weight to 220 Newton downwards. Weight to vertically downward hi na atile hi weight pa hi component lechun chilanga hi 20 sin 37 chilanga hi 20 cos 37. Ale acceleration to displacement to chilang hi chulana chilang hi hotile force hi penala deu we have to take this one. Okay, so this one has no work done. So I say bang wasana atile chila hi so work done due to the weight will be 20 sin 37, that is the force into displacement to 5 1 second na first second so 20 into sin 37 to 3 by 5 into 5 to 3 are 60 joules. Okay, so due to weight to 60 joules so by frictional force on the block. Okay, C part frictional force keep the pen here you have to learn some more work energy theorem conservation of energy. So we will do this later on. Okay, so for now you can skip this C part. Okay. So we have done this. We'll do this much. Okay. Work done due to constant force, variable force. Hizana alang pe chite ni chu meta. Okay. So I hope you understand. I will do this much. Okay. Chi video chalai ngautin abana ko work energy second class home kitina. Work energy theorem tiho kinetic energy, potential energy tiho in sim. Okay. So we'll stop the video here. Thank you.